Hello my nines, this is Miss Yen here. I hope you're all doing well today. I know this may be a little weird, or some of you might find it a bit interesting that you're learning something through the video before class, but I think this would be a great opportunity for you to be responsible for your own learning and watching the video before class starts. So I hope you're all ready to learn the last section of similarity and scale factors. Today in this video, we will be talking about rotation. So if you want, you could pause the video for a bit, take out a piece of paper, get a pencil out, and scribble some notes if you want throughout the video. Alright, so what will we be talking about in this video?
Rotation.
Yep, that's correct. So let's ask the big question first. Rotation. So what is rotation?
Basically rotating an object or figure.
So in this section, we will be talking about rotating an object or a figure. Let's take my red apple here for example. When I rotate this apple in this direction, I would call it counterclockwise. Do you see the word clock and clockwise? Let's take out our clock. Basically, what counterclockwise means is that it's going in the opposite direction to which the clock handle usually goes. So, in that direction. If it is going in the other direction, then we would say this is clockwise. It basically means that it goes in the direction in which the clock hand goes. So what has clockwise and counterclockwise got to do with rotation? Well, in this section we know that we will be rotating objects or figures, but we need to know which direction it's going to go. So before we do some examples, let's go over a few important rules. If your object or figure is going in the clockwise direction, then we would say it's a negative direction. If it is going in the other direction, counterclockwise, then we would say it's going in a positive direction.
Wow, Miss Yen, do I have to remember this?
Yes. It's actually very important to know which direction you're going when you're going clockwise or counterclockwise. But don't worry, I have a way for you to remember this. Let me introduce to you no problem glasses. You will have absolutely no problem to which direction your object will rotate. So when you think of glasses, you think of lens. You will need two lenses in one pair of glasses. So you have your right side of your glasses and your left side of your glasses. Does this look a little familiar? The arrow on the left is going in a clockwise direction, and the arrow on the right is going in a counterclockwise direction. Make sure that your arrows are on the outer side of your glasses. If you're rotating in a clockwise direction, then it's a negative direction. Remember, the left side of your glasses is in the clockwise direction, so N for negative in the clockwise direction. If you're rotating in the opposite direction, which is the counterclockwise direction, then that's a positive direction. So we'll put a P for positive in the counterclockwise direction, which is the right side of your glasses. And there you go. These are your no problem glasses. So some of you might think that these actually don't look like glasses. But let's use our imagination over here. You have a pair of round glasses, and your glasses always sits on your
Nose. Your glasses sits on your nose, and you have your mouth below your nose.
There you go.
Now it looks like someone is wearing no problem glasses.
Now if you want, you can actually draw no problem glasses on a piece of paper, just so you can remember it easier. Now that I've introduced no problem glasses to you, I think it'll be easier for you to tell if it's a negative or a positive direction when you come across clockwise and anti-clockwise questions. Let's do some examples. You'll see what I mean. Let's look at this triangle over here. We know that this section is on rotation, so we'll definitely be rotating this triangle then. But how do I know which direction to go? Well, we have to look at the question first. So the question tells us that we're going to rotate this triangle -90 degrees. Before we tackle this problem, let's look at the center point right here. This center point will help us in rotating our triangle. We'll get to that. Let's go back to my question. I need to rotate this triangle -90 degrees. Let's take out our no problem glasses again. -90 degrees. If you look at your no problem glasses over here, N stands for negative, so you'll be looking at the left side of your glasses. And that tells me I'll be rotating this triangle in a clockwise direction. So let's make a note just in case we forget. We're moving in the clockwise direction. Now how can we rotate this triangle? Since the center point is given to us, we know that that center point is going to be useful. So we're going to use it. The question is, how are we going to use it? The first thing that we're going to do is we're going to take a point on the triangle and draw a line from that point to the center point, like this. So we basically drew a line from one point of the triangle to the center point. And now we can rotate it. We're going to rotate one point of the triangle at a time. Let's rotate this one first. So we're going to take this red dotted line and we're going to rotate it in a clockwise direction all the way to 90 degrees. So now we sort of have an idea where that point of the triangle will be after we rotate it 90 degrees in the clockwise direction. But just one of them is not enough. Let's do another point. We're going to do exactly the same thing. We're going to take the one point in the triangle and we're going to connect it to the center point. I've used a green line here for the second one so that you don't confuse it with a red one. And now we do exactly the same thing again. We're going to rotate it 90 degrees in the clockwise direction. So rotating, and there you have it. Let's do the last one. First things first, we're going to take the last point of the triangle and connect it to the center point, just like we did with the other two. And then we're going to rotate this in the clockwise direction until we get 90 degrees. So I'm running out of space over here. I'm going to use the next page. I'm going to move everything up. Okay, so now I have my three lines that are being rotated. My triangle after rotation will be right here. So one thing to remember when you're doing rotation is that the length that you rotate with is going to be the same. So the length of the red lines will be equal, the length of the green lines will be equal, and the length of the blue lines will be equal. Now let's do the first example on the Cartesian plane. So here we have our Cartesian plane, and we have a triangle on the Cartesian plane. So for this problem, we'll be rotating the figure 90 degrees about point A. Point A over here is 0, -1. I've already plotted it on the Cartesian plane right over there. 0, -1. And if it's just 90 degrees, we know that there's an invisible positive in front of it. So we know it's going in the positive direction. Let's put back our no problem glasses. If we know that we're going in the positive direction, then we know that we're going counterclockwise. Let's take the first point. I've marked it in red so you know which point you'll be rotating. Let's rotate the first one, the red line over here. We know that we need to go 90 degrees in a counterclockwise direction. So we're going to go 90 degrees, counterclockwise direction. Let's do the other point, the green one here. We do exactly the same thing. We're going to go counterclockwise up to 90 degrees. And then we're left with one more point to do. So again, we draw a point from the triangle all the way to the center point, and I've marked that one as blue. So let's take the blue line and rotate it 90 degrees counterclockwise direction. And there you have it, the position of your triangle when you rotate it 90 degrees counterclockwise. Remember, the lengths of the sides have to be the same. So the length of the red ones would be equal, the blue ones would be equal, the green ones would be equal, basically like that. So now we've looked at rotation. There's another thing that we need to look into. It's called the center of rotation. So what is and where is the center of rotation? Before we find out what center of rotation means, we need to first figure out what perpendicular bisector means, because this is very useful in helping our center of rotation. Whew, this is a long word. Let's split it up first. Let's look at bisector first, this word right here. What does bisector mean? A bisector cuts a line into two equal parts. So for example, if you have line AB, the bisector for this line AB would look like that. It basically cut AB into two equal parts. Now let's look at the word perpendicular. Perpendicular means 90 degrees. So if it's a perpendicular bisector, so we will still have the bisector that cuts the line into two equal parts. But there's another thing we have to consider. The angle between the bisector and the line has to be 90 degrees. That's why it's called a perpendicular bisector. Let's do an example on the Cartesian plane. Now I have two triangles on the Cartesian plane. We need to find the center of rotation for these two triangles. So first things first, we need to find two corresponding points. Let's start with point B in this example. Which point is B corresponding to? B prime. So we're going to connect a line between B and B prime. After we do that, what do we need to find? Yep, the perpendicular bisector for this line. Remember, the perpendicular bisector cuts the line into two equal parts and it has to be 90 degrees. Be careful to make sure that you have the one half equal to the other half of the line. Now let's take another line. Let's do C. C is corresponding to C prime, so we'll draw a line connecting them. So remember, it cuts across this line, has to be 90 degrees, and the one side must be equal to the other side. Alright, so there I have my two perpendicular bisectors in red. Where would my center of rotation be? My center of rotation would be where the two perpendicular bisectors meet, so right there. And that point over there is -1/2 and 1.5. That's my center of rotation. So the center of rotation is where your two perpendicular bisectors meet, right there at that point. And there you go. I'm done teaching you about rotation.
We finished the chapter.
We're done with chapter 9. Congratulations, my 9. You have watched your first video on math. If you have any questions regarding rotation, you can ask me in class. Alright, so before I end off the video, we forgot to do a riddle. So let's do one now. Put on your thinking cap. And the riddle for this class is, what goes up and never comes down? Give me your answer next class. Thank you for watching my video. I'll see you all in class.